Okay, so just got done doing the final high-speed spin at 20,000 G and transfer the supernatants to new tube. So next step is we're going to treat with a series of enzymes versus RNase A and then Proteinase K. So RNase A will degrade RNA, Proteinase K will degrade protein, and then we're left with DNA where we're going to precipitate. So first thing is to do, we'll make a dilution of RNase A stock. We'll go get that in a minute. So what we'll do is we'll take a tube here. I typically just use PBS to dilute it in. So just get a new microfuge tube. I'm going to add 350 microliters of PBS. Only one tube right now. Okay, and then we're going to grab the RNase A. That's over in this freezer over here. Okay, so this box labeled enzyme has, up at the top, we've got RNase A, Proteinase K, and glycogen. We actually need all three of them, so I'm going to go grab tubes of all of them. And this RNase A is a 10 milligram per mil stock. And so what we're going to do is dilute everything, and rather than try to add really small volume to all 12 tubes, we'll dilute it in a larger volume of PBS. So we're going to take 14 microliters of this RNase A and add it to the PBS. This is enough. Essentially we need 1 microliter per tube. And anytime you're making up something like this, you typically you'll use more than you plan, or you might lose some during pipetting. So we're going to need, 14 microliters here. I'm going to take 14 microliters. Again, we store these enzymes at minus 20. They actually ship them at room temperature, so they're reasonably sensitive, reasonably resistant to temperature. So. And I'm going to vortex this real quick, just to mix it up, so everything's nice and mixed. And then I'm going to take a P100 pipetter, and I'm going to pipette 25 microliters. And we can do this relatively quickly. It's one of the advantages of using a larger volume. It's easier to just easily dispense 25 microliters. It's much easier to do that than 1 microliter. And part of this reason, again, is it dilutes the RNase A and allows you to pipette a lot quicker than trying to do 1 microliter at a time 12 times. Because if you try to pipette 1 microliter, it's not going to come out. You can't just quickly dispense it out. You have to add it to the liquid itself. And so what I'm going to do is close these tubes. And we're just going to vortex real quick. Two at a time here. Just to make sure the RNase A gets mixed with the sample. RNases are very, especially RNase A, are very tough and strong enzymes. They're actually resistant to even autoclaving at very high temperatures. And we have a lot of RNases on our skin, and so one reason why RNA is often harder to work with, because it's somewhat more or less stable and more sensitive to things even on our hands. So we're only going to let that go for a couple minutes. So 2 minutes room temperature is fine. Next we're going to add Proteinase K. We're going to do the same sort of approach. So I'm going to take 350 microliters of PBS. I'll use the P1000 pipetter. Add that to a tube. And I'm going to add same amount, same volume. So I'm going to add Proteinase K, and this is a, does it say it on there? I may not say the concentration. I believe it's 20 mg per mil. We'll take 14 microliters, add that to the PBS, vortex real quick to mix. And just like before, I'm going to add 25 microliters to each tube. And just real quick is the way to do it. You don't need You don't need to stick the tip in the sample. 25 microns is a large enough volume, will come out very readily just by pushing down the pipette all the way. Okay. The last thing we'll get to in a few minutes is glycogen. That'll take some time to thaw out. That's not frozen. So the other two enzymes, if you notice, they're still liquid. They're stored in a glycerol, so the enzyme does not freeze. Freezing the thawing is often a bad thing for proteins and enzymes. So for this, we're going to heat it at 60 degrees. So we use this. Really, there's, I think it's set for 56. Anywhere from 55 to 65 is fine. Proteinase K can, just like many enzymes, have optimal temperatures, often 37 degrees. Every enzyme's a little bit different. Some enzymes are a little different. So Proteinase K works best at between 55 and 65 degrees. The RNase A, we just did a room temperature, it's fine. So again, enzymes are a little bit different. And we're just going to stick the tubes in here. And we don't really set the time. You can set the time. We can set the speed of shaking. We'll just hit start here. And it's right now room temperature 26.1 degrees. This will heat up pretty quickly. Within probably 2 or 3 minutes, you start to see it'll beep. It'll tell you the samples are at the right temperature. You can see the temperature's already starting to go up, so it goes up pretty quickly. And we do this digestion for 10 to 20 minutes. I usually do at least 10 minutes, but you go longer, it's not going to be too. It shouldn't be too negatively affect anything. So we'll let that go. While we're waiting, I'm going to thaw this glycogen out. Like you see it starting to thaw. I'm just going to prep that for the next step. So we're going to do the exact same thing. We're going to take some PBS here. Still a little bit frozen here. Okay, it's probably thawed enough. Take 14 microliters out. Add that to the tube. This real quick. I'm going to label it so I know what it is. Okay, so now we're done with all these 3 things. I'm going to put them back in the freezer. Don't leave them out too long. Yeah, let's just store this box labeled enzymes. Quick check the shaking. You can see it's already up to 50 degrees, so it's been about 2 minutes or so, but we're getting up to 60 degrees quite quickly. We'll just let it go. So we're going to let this go for about 10 to 20 minutes, and then we'll take them back off and add the glycogen and do the next step to start the precipitation.